If you don't have a Mechlin Railway, you have to get to grips with switch polarity reversal, which is not that difficult in principle. In this video we show you how to do this with the various points and devices. With turnout polarity reversal, the polarity of the track current is changed on part of the rails depending on the position of the turnout. This is done to improve the power pickup of the locomotives. There are also turnouts with insulated frogs, but then there is a risk that small locomotives will get stuck on the turnout. In our first example, we show how this can be done with the help of an ESU switch pilot servo and the switch pilot extension. Firstly, the servos must be installed. There are various solutions for this. We do it as we showed in our previous video by simply gluing a few pieces of wood under the layout and screwing the servo onto it. Then we pass the adjusting wire through a hard piece of plastic so that we have a leverage effect. Then we need to calibrate the servo. There should be no jittering in the end positions. If there is, then the servo is trying to regulate further than it can. If you let it run like this, the servo will be damaged at some point. If the switch extension is already fitted, it must be activated in the settings or via the CV programming. If you then let the servo run, you will hear a clicking sound during the movement. This is a relay in the extension box, and it then changes the output for the frog terminal. We also set it so that the relay switches in the middle of the control process. How do you wire the whole thing? You solder a cable to the frog. Usually one is already connected at the factory. There are two relay connections labeled A and B for each servo output. We need one each, whether it is A or B is irrelevant. The servo has two positions, stupidly also A and B, but this has nothing to do with A and B on the extension. A is usually used for the branch as it is triggered with the red command. In this case, outputs 1 are active. Outputs 2 are then active for position B. So we connect the center wire to the center terminal that says COM. Then we connect connections 1 and 2 to the track current. If the connection is active, it should have the opposite pole to the outer rail to be traveled on. It is best if the traction current is not yet switched on and there is no locomotive on the track so that we can measure with the multimeter whether we are correct. We set the points to straight ahead, then place the multimeter on the outer rail and on the frog. If it beeps, we have a short circuit. Then it's wired incorrectly. Then we swap the track current connections. Now we measure again. It should be correct. If it still beeps, then there is another short circuit. We have to find it first. To do this, we remove the connection on the frog and search for it. Only when we have found it can we continue. In our next example, we do the polarity reversal with a Totos turnout machine. This has two built-in relays. You can hear the relays click when switching. The connection also takes some getting used to. The track current is soldered to the two COM connections in the center. These are labeled 4 and 5. Then we solder a cable between connections 2 and 7 and connect the frog supply from one of these two connections. We straighten the points and drive exactly as with the switch pilot. Use the multimeter to measure whether the frog has the opposite pole to the outer rail. If this is the case, we can leave the traction current connection as it is. If there is a short circuit, we have to swap the connections. The modules we received already had a 3-way point. I wouldn't have installed one for operational reasons, but since one was already there, we'll go through this case. A 3-way turnout has 3 frogs for 2 drives. With 2 drives, there would actually be 4 positions, but branching off twice is not a valid option. We therefore do not need to take it into account. We create a logical table with the positions of the drives and the respective polarity. For each position, one frog is plus, the other is minus, and the third is not taken into account. If we add up the logic table, we see that drive 1 switches frog A and drive 2 controls frogs B and C respectively. This is therefore somewhat simpler than expected. As already mentioned, if both drives were on branch, a short circuit would occur when passing through, especially because we have an asymmetrical turnout and this is possible. And finally, we also have trick C-track on our new layout. Normally, ballast tracks are not polarized, but with the C-tracks, you can configure this. If you turn the points around, you can see a jumper on the underside. Depending on the position, the frog uses polarity reversal. If you want to run with that, you can no longer cut open the turnout. This is not a problem for us because we control the points by computer. We then always make sure that the turnout is run in trailing direction. During construction, we discovered that the slender turnouts are polarized X-works and the steep ones are not. It's best to check with a multimeter whether it's the way you want it. So, that's it. If you want to find out more about polarity reversal, take a look at the video in which we convert 2 wire turnouts to center conductor operation.